As students, we spend decades in the classroom, but we're ignoring an invisible threat. Traditional whiteboard markers contain up to 20% VOCs, petrochemical toxins that could cause nausea, lung inflammation, and headaches.
Especially in poorly ventilated classrooms, these VOCs, like xylene and isopropanol, directly threaten the health of millions of students worldwide.
For me, this wasn't just a statistic. Since installing a whiteboard in my bedroom, I've experienced these symptoms on a daily basis. We decided to challenge the status quo that forces students to choose between their health and their grades.
Thus, we created PureInk. It's a respiratory-safe marker ink that replaces fossil fuels with green chemistry.
Although scientists have tried to develop alternatives before, unfortunately, they all fall short. For example, scientists tried to develop water-based whiteboard marker inks. However, they smudge easily and still release a small amount of VOCs since they still rely a lot on petrochemical solvents. Also, scientists have tried to develop dragon fruit-based or chicken wing protein-based pigments to use the whiteboard markers. However, they still rely on toxic petrochemical solvents to make the ink flow, aka they still release VOCs. We realized only by reinventing the entire chemical matrix of traditional whiteboard markers can we truly create a safe environment that removes these toxic and invisible chemicals from our classrooms.
We center our ink around ethyl-lactate, a non-toxic solvent produced from agricultural waste through fermentation.
Combined with natural shellac, polyethylene wax, triethyl citrate, and soy lecithin, our marker ink matches the performance of traditional marker inks in terms of erasability, clogging resistance, and color intensity, but with
Zero toxin emissions.
This isn't just a concept. Through a series of optimization trials, our study in phase 1, we have tested the industrial performance of our formula against various metrics. In our study, we synthesized 5 formulas by changing the ratio of wax and triethyl citrate. Then, we rigorously tested them on 3 main criteria: erasability, color intensity, and continuous ink flow.
To ensure a fair test, we kept the multiple variables the same, such as the room temperature and the same test surface. So we also created multiple devices to maintain the same ink application and erasure pressure.
With our results, we identified Formula A and B are optimal for color intensity. However, Formula A leaves a big stain when erased. We successfully identified the exact weight ratios of triethyl citrate to wax in order to show the best performances, Formula B. Our data successfully proved that a zero toxic, zero VOC marker that is sustainably sourced is chemically possible.
As you can see, I'm applying our ink on the whiteboard right now. Our ink actual optimization works almost just as well as traditional markers. It also erases easily, as we have tested this in our experiment.
Because we're handling flammable biosolvents, we utilize professional equipment such as professional grade fume hoods, high precision mass balances, and also water bath heating matrices to ensure absolute safety. To mitigate the risks associated with handling chemicals, we've also developed a risk assessment for our experiments to minimize the risk for us, as well as for the manufacturers and consumers when we ultimately mass produce the products.
Of course, scaling a novel chemical product comes with its technical risks. For example, because our plant-based resins are naturally thicker than synthetic plastics, our ink currently has a higher viscosity, meaning it doesn't flow through standard marker nibs as easily as we want to. Additionally, the drying time of our current marker ink is about 1 to 2 minutes. Because our solvent doesn't have the advantage of high boiling point as VOCs, meaning it sometimes can be wiped off not as cleanly or seamlessly as standard whiteboard markers right after being applied.
After completing phase 1, we are also proactively solving the above issue in our phase 2 stage. By adding bioethanol to our formula, further grinding the pigment particles, and also adjusting our plant-based releasing agent to ensure the effortless erasing. We are on the track to achieving a market-ready ink by the end of 2026.
Our implementation timeline is also very realistic and highly scalable. By 2027, we move into phase 3, which is supply chain integration. By using a method called B2B licensing, we don't need high capital to purchase expensive equipment and factories, but we can also mass produce our ink.
To do this, we are currently filing a provisional patent for our specific chemical formulas through the IP Department of Hong Kong. Then, we will license the formula to existing manufacturing giants like Pilot and Expo in terms of whiteboard markers. This allows our VOC-free ink to be directly injected seamlessly into existing manufacturing lines and barrels. This allows for lower manufacturing costs.
We will also ensure regulatory compliance by calibrating our ink against various international standards. For example, we'll comply with the ASTM D4236 to verify our ink's minimal toxicity, and also ISO 11892 to quantify our ink's VOC reduction.
You might be thinking, wouldn't these markers be really expensive to produce? Actually, it is the exact opposite. We calculated that for us to produce one whiteboard marker with 5 ml of ink, it only costed us less than 3.5 HK dollars. By just selling at less than $7, we would have achieved a 50% profit margin, while our competitors sell at 10 to 15 Hong Kong dollars. To raise funds to bulk purchase raw materials, we will apply for local/regional green innovation grants or institutional environmental seeds through our verified scientific findings.
Focusing on SDG goal 3, good health and well-being, our ultimate impact is to set up a classroom where students can learn and have fun without health risks. By replacing standard whiteboard markers with our solution in just 20% of Hong Kong, we can remove hundreds of kilograms of airborne toxins. Because whiteboards are universal standards, we can scale our solution to every corner of the world easily.
We are making learning safe and joyful by replacing toxic chemicals with our innovation.
It's time to stop compromising student health for convenience.
We're not just making a better marker, we're making learning healthy for millions of children.
Join us in making a healthier life for millions of students.
We are PureInk.